Good morning. We are getting ready to start another two-day lesson with lesson 27. We are going to go through what you need to do for day one. On the word problem, make sure you watch that Eureka video first with Mr. Waldorf, and then please remember to use cubes and read, draw, and write before you do the word problem. All right, so I would probably do that word problem last. All right, so then wait a minute, I almost forgot. Then there is a sprint that you need to do. There is a sprint. Yep, there's that sprint. And again, this is not timed. You're going to do side A and side B. Get the whole thing done, all 44 problems, because they are excellent practice for mental math experiences. And then you are going to, after you watch that Eureka video, you are going to come over and we are going to be doing the first part of this problem, which is make each equation true. Now if you were watching what Mr. Waldorf was doing, this should not be too hard for you. 100 is equal to how many tens? 100 is equal to 10 tens and how many ones? 200s is equal to 1 100 and how many tens? And 2 100s is equal to how many 1 100 and 10 tens and how many ones? If you need to, I would strongly suggest that I know I did this for myself, but I took a piece of paper and drew myself a place value chart, and I started off with 100. And when I show it to you, I'm going to show it to you like this. 100 is equal to how many tens? So you're finding out how many tens is the same as 100. Okay, and then I came down and I did the next one. 100 is equal to, they said 9 tens, so I did 1, 2, 3, 4, 5, 6, 7, 8, 9 tens, so that was 9 tens, and you have to tell how many, sorry about that. 100 is equal to 9 tens and how many ones? And then I did the same thing over on the other side of this page with my hundreds, tens, and ones. You don't have a copy of this, you're going to have to make it. Miss Mulder made this for us, and I know you've seen her use it before. You're going to do the same thing with 200s. 200s is equal to 1 100 and how many tens? And then on, this would be, oh sorry, I should have been numbering this. This is letter C, and letter D is 200s. Mr. Waldorf went over this with you on the video. 200s is equal to 100, 9 tens, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you have to tell how many ones. All right, so if you'll do it using your place value chart and your chip model, I think you'll find it much easier to do. Okay, so this was the A problem and this was the B problem, and when we come back I will share with you what I did on those two problems. If you understand how to do this, the rest of this will be very easy for you. So then you have to solve vertically using chips and the place value chart. Remember that you need to unbundle when necessary. So you're doing problem A and problem B. Now, there is a separate exit ticket. Let's see if I can. The exit ticket is not in your packet, my friends, because there was only 2 problems for you to work on the practice sheet. I am giving you a different exit ticket, and again, you are going to have to write this down because you don't have this in your materials. The exit ticket will be problem A and problem B. Okay, you're going to be doing 100 take away 59, and you are going to use the same vertical form as you did on these 2 problems. So vertical form and the chip model for both 100 take away 59 and 100 take away 85. And we are going to want to see the same steps on your exit ticket as we did on the practice pages that you did. All right, so that's the assignment for today, for day 1. This is the exit ticket for day 1. And you are going to need to pause the video and then come back and we will go over these pages with you. All right, so pause the video. And are you back? All right, let's come on back and see how you did. So let's go ahead and start with the word problem. After you, of course, have watched that Eureka video and you have worked all of these other problems that you need to do. So Mr. Ramus has 139 pencils and 188 erasers. So he's got pencils and erasers, and they want to know how many more pencils are there than erasers. Okay, so let's see how you did on this. So I know that I'm trying to find the difference between how many pencils and erasers there are, so I can know how many more pencils there are than erasers. So I'm going to start with my number bond or my bar model, and I'm going to start with 130. Whoops, that's not what I meant to write. 139 pencils. Remember, I'm looking for the difference between pencils and erasers. I do know how many erasers there were. There were 88 erasers. So I'm getting that, and what I am trying to find out is how many more. How many more pencils, this is the big question I have to answer, than erasers? And I don't think this is going to be too hard for us because I think we already know how to do a number bond there. So I am going to start with an equation of 139, which is my whole. I'm going to take away the part that is erasers, and that should tell me how many more pencils I have than erasers. So I'm going to start with changing this into the vertical form. 39 take away 88 equals, and I am going to give myself, yep, you guessed it, a place value chart with hundreds, tens, and ones. And I know that I am going to have to represent my whole, which is 100, 3 tens, and 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to double check that I did that correct. 100, 110, 120, 130, 131, 132, 133, 134, 135, 136, 137, 138, 139. Oops, I put in one too many. It's a good thing I went back to double check my work. You should always do that. I'm going to double check that. 100, 110, 120, 130, 131, 132, 133, 134, 135, 136, 137, 138, and 139. So I'm on the right track. So now the first thing that I need to do is I'm going to look in my ones to see if I can take 8 ones from 9 ones. Do I need to decompose a 10? Nope, I don't think I do, because I can take out 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. That leaves me with 1 1. So, whatever I do here, I need to do, I didn't have to do anything there. So I'm leaving that just the way it is. I didn't have to do any decomposing other than transferring the fact that there was 1 left over after I took 8 ones away from 9 ones. Now I'm coming over to my tens, and I'm asking myself, I only have 3 tens. Can I take 8 tens away from 3 tens? 8 tens from 3 tens, or 3 tens take away 8 tens. I cannot do that. So I'm going to need to get some more tens by unbundling 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so now I need to think, have I made some changes here in my chip model that I also need to make in my vertical model? Well, do I still have 3 tens or do I have more than that? Well, I hope you said, well, Miss Starr, you now have 13 tens, so I need to show that in my vertical model. Do I still have 100? Nope, I had to exchange or decompose a 100, which left me with 0 hundreds. Can I continue my subtraction process now that I have enough tens that I can take 8 tens away? So let's go ahead and take 8 tens from 13 tens, because that's what I have here. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. Well, that looks like it is leaving me with 5 tens. I'm going to bring that over here because that's how many tens I had left after I took 8 tens out of the 13 tens. Now I'm looking over in my hundreds. I don't have any hundreds left. So 0 100s take away 0 100s is going to give me 0 100s. So I know that 139 take away 88 is 51. So does that help me answer my question that there are 51 more pencils than erasers? I think it does. There are, oops, that would be helpful if I'd write that word correctly. There are how many? 51 more pencils than erasers. E-R-A-S. Oops, I still didn't spell that right. It must be getting late in the day. E-R-A-S-E-R-S. Yep, there we go. So there are 51 more pencils than erasers, making my number bond exactly working perfectly. All right, so now we are going to go over to this page. So let's take a look at how many tens there are in 100. So I am looking at how many tens are in 100, how many tens are equal to 100. I said there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tens is the same as 100. So I know that is 10 tens. Okay, then I'm coming down to, now I'm going to be looking at how many hundreds is equal to. They told me that I had 9 tens, so I'm counting 10, 20, 30, 40, 50, 60, 70, 80, 90. I still have to get to 100. 101, 102, 103, no, sorry. 10, 20, 30, 40, 50, 60, 70, 80, 90, sorry, 91, 92, 93, 94, 95, 96, 97, 98, 99, and 100. So I know there are 10 ones. So 100 is equal to 9 tens and 10 ones. How do I know that? Because I just got finished counting it. I'm going to count it one more time because my paper was down kind of low. 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. 2 different ways to represent 100. This was a 2-step process and a 1-step process. So now I'm coming over to, now 200 is equal to 1 100 and 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, and 200. So I know that it has 1 100 and 10 tens. All right, so now let's take a look at the second one here, part D. 200s is equal to, it's equal to, whoops, I forgot to put my 1 100 in there. Shame on you, Miss Starr. So that is equal to 1 100. Wait a minute here. 1 100. Oh yeah, I'm going for 200. 110, 120, 130, 140, 150, 160, 170, 180, 190, 191, 192, 193, 194, 195, 196, 197, 198, 199, and 200. So how many ones was that? That was 10 ones. All right, so hopefully you were very successful on that part. If you were still a little bit confused, you might want to go back and re-watch Mr. Waldorf talk about that again, drawing out the tens and ones on a place value mat. Now we are going to come down to the next two problems that you needed to solve, and that would be, we're going to solve vertically with the chip model, and we're going to unbundle when necessary. So we are going to change 100 into the vertical model. 100 take away 61. I'm going to look closely at 100, and this one's going to be pretty easy to represent because there's only one 100. I have 0 tens and 0 ones. So when I start thinking about subtracting, can I take 1 1 away from 0 ones? No, I can't. So normally I would go over and unbundle a 10, but there isn't one. So I'm going to have to start unbundling in the hundreds so that I can create some tens and I can also create some ones. So let's start by unbundling 100 and moving that over into our tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now I have 10 tens, but I still need to have some ones. So if I unbundle a group of 10 and move it over into my ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now I have unbundled a 10 and I have changed it for 10 ones. I think I have enough to be able to do what I need to do now. So I have 10 ones to work with, 9 tens, and 0 hundreds. I'm just writing that down so I know where I am. Whatever I did in my chip model, I also have to do in my vertical model. Do I still have 0 ones? No, now I have 10 because I unbundled a 10 for 10 ones. So I don't any longer just have 0 ones, I now have 10 ones. Do I still have 0 tens? Well, nope, I unbundled 100, which gave me 10, but because I had to unbundle another one, that only left me with 9. So I'm going to put that in my vertical model. And do I still have 100? Nope, because I had to decompose that, which means I now no longer have 100. So now I'm back to getting ready to subtract. Can I take 1 1 away from 10? I certainly can. Here it goes. When I take 1 1 away from 10, I don't have 10 anymore. Now I have 9. So I now have 9 ones, which I'm going to put in my vertical model. Can I take 6 tens away from 9 tens? Well, here's my 9 tens. I'm going to take 6. 1, 2, 3, 4, 5, 6. That leaves me with 1, 2, 3. So no longer 9, now I have 3. So I'm going to put that in my vertical model too, because 9 tens take away 6 tens is 3 tens. I have 0 hundreds, so 0 hundreds take away 0 hundreds gives me 0 hundreds for a grand total of 3 tens, 9 ones, which is the standard number 39. Let's move on down to problem B. So problem B is 100 take away 79, which I am drawing in the vertical model. I'm going to take a really close look at that number. Here we go, close look at 100. And if I'm going to represent this on my chip model, again, I only get to put in 100 because I have 0 tens and 0 ones. Okay, I can do this. It's all good. So I'm going to ask, can I take 9 ones away from 0 ones? Nope, can't do it. and I don't have any 10s that I can decompose, so I'm going to have to come all the way over to this 100 and decompose that 100 to get some 10s. All right, so that's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now I've got some 10s that I can work with, and that will help me to get some 1s. So I'm going to decompose a 10 and exchange that for 10 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so that tells me now that I have 10 1s here, and I have 9 10s, and I have 0 100s. So if I do it in the chip model, I need to come over and show that in my vertical form. So do I still have 0 1s? Nope. Now I have 10. Do I still have 0 10s? Nope. Now I have 9. And do I still have 1 100? I do not. Now I have 0 100s. Whew, I think I am ready to finally start subtracting. So I'm going to take 9 1s away from this 10 1s. 9 1s from 10 1s, or 10 take away 9. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Ooh, there's no longer 10. Now I just have 1. I need to make sure that I show that in my vertical model, because 10 1s take away 9 1s is 1 1. Now, can I take 7 10s away from the 9 10s that I still have left here? I certainly can. Here we go. 1, 2, 3, 4, 5, 6, 7. That is leaving me with 2 10s, and I need to show that as well in my vertical model, because 9 10s take away 7 10s is 2 10s. Now I have 0 100s. So if I have 0 100s take away 0 100s, which is what I have there, I have 0 100s. 2 10s plus 1 1 in standard form would be 21. All right. Now, as I said, the exit ticket is right here, and I'm going to show it to you now so that you can see what you're going to need to do with your exit ticket. Okay, so my friends, I'm going to remind you that your exit ticket is not in your packet today. There was not enough problems. I wanted you to do a couple of more practice problems, and so you're going to have to write this exit ticket down. So you can pause the video, make yourself a place value chart for the chip model, and you are going to be subtracting 100 take away 59 using the vertical form the same way you just did a few minutes ago. And you're also going to be doing that same thing with 100 take away 85. And we are going to want to see all those same steps that you did when you did these two problems. I'm going to need to see all those same steps as you do when you do the exit ticket for today. And then you are going to need to send this to your teacher. Send this to your teacher, and then she will check and see how you did on your exit ticket. All right, and there we go. So now that you have looked at everything and we've worked all those problems, you just need to finish things up, get your exit ticket done, and send it to your teacher. And for right now, I'm going to say goodbye and have a great day of learning.